Good. So what do we got tonight?
We have right triangle trigonometry.
Okay. Do you have problems that you can verbalize, or are these kind of things you need? As long as they're right triangles, or probably you can verbalize.
Yeah, I can verbalize it. Let's see. We have, so it says solve triangle ABC using the diagram and the given measurements.
Okay.
So it's the right triangle, and then on each corner, yep, it's got A, B, and C, and then it has for the side lengths are little a, little b, and little c.
Okay, so that's little a, that's little b, and that's little c. In other words,
Yep.
always opposite the big number, or the bigger one.
Okay. All right. And then for this problem, it gives us that big A is 19 degrees and lowercase b is 4.
All right. Then I got to draw a different triangle. Is it still a right triangle?
Yeah.
19 degrees, right?
Yep.
Little b is 4,
Yep.
and c is a right angle.
Yes.
Okay, let me erase this picture I have over here. That'll confuse. Okay, and what do they want to know?
We have to solve for all the other variables. So,
Solve for all 6 pieces of the triangle?
well, we have capital A, that's 19 degrees, and then the lowercase b is 4.
Yeah, when they want you to solve a triangle, it means they want all 3 angles and all 3 sides.
Right.
So what's angle B?
That will be 90 minus 19, which is
71.
71. Yep.
Okay. Now we can use trig functions to figure out side A and side C. So let's see if we can come up with some equations.
Okay.
If I say the cosine of 19 degrees, what's cosine equal to?
That's equal to, it's,
SOHCAHTOA. Learn that like you know
oh,
your name and don't forget it.
okay. I thought you meant like the,
Well,
opposite thing.
knowing SOHCAHTOA tells you how to solve this problem.
Adjacent
Because
over
cosine is adjacent over hypotenuse. So what's the adjacent side to A?
it would be 4, no? Oh, yeah, that'd be 4.
Well, first of all, there's always 2 adjacent sides, okay? The adjacent side they're referring to is always the one that is not the hypotenuse.
Okay.
Okay, so C is an adjacent side, but that's not the one they're referring to. They're always referring to the 4.
Okay.
And then it's over the hypotenuse. There's a little over right there. Hidden. So sine is the opposite over the hypotenuse, cosine is the adjacent over the hypotenuse, and tangent is the opposite over the adjacent. So it's 4 over c. And now notice there's only one unknown in that equation, c. Cosine of 19 degrees is a number. You can get it on your calculator. But if you do the algebra, what you end up with is 4 over cosine of 19. Make sure your calculator is in degrees, not radians.
Right.
What do you get? for C? This is little c, actually.
I got 4.23.
Well, so far we're okay. There's a rule in trig, or with triangles, that the largest angle has to be opposite the largest side, and the smallest angle has to be opposite the smallest side. So far we haven't violated anything.
Right.
Now, how can I solve for A? What trig function takes A into consideration?
Sine
That's
does.
what you always have to do. The sine, okay. So tell me what the equation is.
That would be sine 19 equals A over 4.23.
Okay. So A equals 4.23 times the sine of 19. What number is that?
That is 1.37 or 1.38.
And notice that if we just do a quick ballpark check here, we've got the smallest side of the triangle opposite the smallest angle. We have the middle angle opposite the middle side, and we have the largest angle opposite the largest side. So it passes our ballpark check. And as all that really does is kind of clues you in as to whether or not, well, maybe you used radians instead of degrees or something. If you did use radians instead of degrees, then this would not pass the ballpark check.
Okay.
Okay, what else you got? What other similar?
So this next problem uses the exact same triangle.
Okay.
And it gives us capital A equals 29 degrees. And then lowercase b equals 4.
Okay. Give me everything you need to do to solve this triangle.
C is the hypotenuse, and then...
Well, step by step, let's do it. So far, we only know three things. We know 29 degrees, we know a right angle, and we know side 4.
Right.
How do we get everything else?
Capital B for the angle would be 61 degrees.
Okay, that's a start. Now we know all three angles.
And then we could use that to find with the bottom.
I need an equation. Always be thinking in terms of what equation can you write, and always start that equation with the trig function.
Okay.
Which trig function are you going to use?
I could use sine for the...
Well, okay, sine of what?
Sine 61.
Okay, that will work.
Yep.
As long as you use 61 degrees. What's that equal to?
Equals 4 over little c.
Okay, so what is little c equal to? 4 divided by sine of 61.
I got 4.57.
Now there's only one last thing we need, which is side little a. We have all three angles, we have two sides. So what can I use, what trig function to get little a?
Should we stay constant with the 61 degrees, or does it matter?
It doesn't matter. You can actually use sine, cosine, or tangent to figure out little a.
So we could do sine of 29 then.
Okay.
Equals a over 4.57.
Okay. And you can kind of see that you're going to accumulate some round-off error here.
Yeah.
Because We rounded off 4.57, and we're going to multiply it by the sine of 29 degrees, which is going to be rounded off again. So sometimes it doesn't really pay to round it off. You're going to get a less accurate answer. What does that give you for side A?
I just used my calculator from the answer of the sine, and I multiplied that by sine 29 and got 2.22.
Okay. Makes sense. It's the ballpark answer for sure. Do the instructions ask you to round off your answers to the nearest tenth, hundredth, thousandth, what?
It doesn't say.
Okay. I don't know if there's a standard. Is it standard to round it off to the nearest hundredths? Which is what we've done. That's to the nearest hundredth. That's to the nearest hundredth.
Our teacher's not very consistent with that, so I'm not sure.
Okay. Well, as long as he doesn't specify, then you're probably okay with these answers. If he wants you to round it off to the nearest tenth, different story.
Yeah.
Okay. What else? These are pretty straightforward. As long as you know SOHCAHTOA or SOHCAHTOA, you're going to be fine.
All right. Let's see. I have one where it says find the area of the regular polygon with point P at its center. So there's a polygon, and then it has a point in the middle of the polygon.
Do you know how many sides the polygon has?
There are 6. So would that be a hexagon?
Yes, it would. And here's how I draw a hexagon. There's the top half, 3 sides, there's the bottom half. All sides are equal, all angles are equal. That's what makes it a regular hexagon. In other words, the word regular means all sides are equal, all angles are equal. Okay. And you have a point in the middle, and let me guess, they're giving you this distance right here.
They didn't actually. They gave us
this right here.
They gave us that each side is 8.
That's it?
Yeah.
Okay. So each side is 8. And they want the area?
Yeah.
Okay. So the one thing you can do with all of these regular polygons is you can break them up into triangles.
Okay.
Okay. Notice that I would have exactly 8 triangles and they would all be the same.
Okay.
So if we can solve one triangle, we're just going to multiply the answer by 8 and that's our area. Let's take a look at this triangle here. That is that triangle. Okay, that's the only thing we know at the moment. Do we know anything about this angle up there?
That would be 60 degrees.
Yeah, it's got to be 360 divided by 8. Or divided by 6, excuse me. Because there's 6 angles.
Right.
Now we know that that is a 30-60 right triangle. Correct?
Correct.
So now let's just look at the right triangle part. What's the bottom dimension?
Hold
on.
For the side?
I did this wrong. Just a second.
Okay.
This is 60 here. And that's 60 there. And that is 30. So the little triangle here if I can figure out how to dimension this, I will have basically solved the problem. What's this bottom dimension?
For the side?
What's x?
X is 4.
Okay. Because we know a median bisects the bottom. So now I know 4. Can I figure out y? Using a trig function.
Yes.
Which trig function?
We can use
Notice you cannot use sine or cosine.
yeah, so we'd use tan. So
okay,
we could do
so tan of what is what?
tan of 60 equals y over 4.
Okay, so y equals 4 times tan of 60. What's y come out to be?
It equals 6.9.
Okay, this brings into question whether you want to use decimal answers or radical answers. If you're using your calculator, it's going to give you decimal answers.
Right.
If I'm looking at the tan of 60, that's the opposite over the adjacent. That's actually, if I look at a normal 30-60 right triangle, where this is the 60, this is 1, that's root 3, and that's 2. So the tan of 60 is root 3. So y is actually 4 times root 3. That's the precise answer.
Okay.
That will round off to 6.9. But your teacher might be asking for the precise answer and not the rounded off answer.
Okay, I think that might
happens. Okay, instead of writing 6.9, let's put 4 root 3.
All right.
Now,
so then the this would be 8.
What's the area of that little triangle? The formula for area of a triangle?
I'm blanking on that.
1/2
Is it like
base times height.
Oh, okay.
It's not one you want to blank on. That's one of the most important formulas you can know in geometry. This is the formula for the area of a triangle. So it's 1/2 the base times the height. So that's 8 root 3. That is the area of that right there. You with me?
Yeah.
How many of those are in that regular hexagon?
12.
Right. There's 6 big triangles, 12 little triangles. So 12 times this number is 96 root 3, and that's really the correct answer.
Okay.
Now, if your teacher is asking for it in radical form, this is the correct answer. If he's asking for it in decimal, then usually they're going to give instructions as to how to round it off. How many places to round it off to. So if he's not asking you to round it off to 2 places, he's probably asking for it in radical format.
Okay.
Which would be 96 root 3.
Right. Okay.
Okay. And the way you get the radical formats on all problems like this are going to be with these 2 triangles. One is a 30-60, 90, and the other is a 45-45, 90. And the 4545 has dimensions of 1, 1, root 2. So all of your trig functions of your common angles, which are 30, 45, or 60, all give you specific radical answers that are exact. So you should always use the radical answer if you have it available. Now, that's not the same as the previous problem we just worked on where you had a 19-degree angle. We don't know what the radical answer is for the sine of 19 degrees. All we do is have a calculator that gives us a decimal. So that is a different problem. But if you can indeed come up with a radical answer, that's always the best answer. This is by far the most accurate answer you're getting.
Okay.
All right. All right. What else?
So there's one, it says, so we have the opposites of the like sine, cosine, and tangent.
Yeah, they're not opposites, they're reciprocals.
Yeah, reciprocals, yeah.
Yeah, the sine's reciprocal is equal to what?
That would be
Cosecant.
okay, that's what it is.
What's the reciprocal of cosine?
It's SEC as an abbreviation for me, but
Okay, notice one thing about this. You got an S, you got a C. You got an S, you got a C. Don't ever put cosine with cosecant or sine with secant, because then you'd have two C's or two S's.
okay.
So that's how you remember it.
All right.
Because it's easy to get these confused. And tangent's easy. What's the reciprocal of tangent?
Cotangent.
Yeah, nobody forgets that.
Yeah.
Okay? But these other two, it's easy to get them mixed up. So just remember the opening letter has to be opposite.
Okay.
You start with sine, it's not going to be a secant. And by the way, if the first statement is true, then this is true. And this is true. So there are actually 6 reciprocal identities, is what they're called. Make sure you know all 6. But you really only have to memorize 3. I mean, the other 3 follow.
Okay.
Okay? All right, so knowing these, now what's the problem?
It says to use our calculator to find the function.
Okay.
But our math teacher said we couldn't use it to find the reciprocals of sine, cosine, or tangent on the calculator.
Okay.
Tell
me what the problem is, and I think I can direct you properly.
Okay, cosecant 80 degrees. And he wants us to round to the first 4 decimal places.
Okay, so here's what you need to do. What kind of calculator do you have?
TI-84.
Okay, what's the reciprocal of cosecant?
It would be sine, so it'd be opposite over hypotenuse.
Right there. In other words, what you want to put into your calculator is 1 over sine of 80 degrees.
Oh.
That's how you do these.
Okay.
In other words, you still use those 3 primary trig functions that are on your calculator, because they don't have a cosecant button on your calculator.
Right.
So you have to do it as the reciprocal of what you know its reciprocal identity is, which is sine.
Okay.
Okay. And again, this is going to give you a decimal answer, not a radical answer, so you will have to round it off. So let's just start rounding it off to 2 places. So what's this equal to?
1.01.
What was the next digit? Just to make sure I...
Oh, it was a 5, so it'd be 1.02.
Okay, that's why I asked.
Yeah.
Let's round it off to 2 places, or the hundredths place. Okay, what else?
Okay. Let's see. That actually covers everything we reviewed.
Okay, well, that's fine. It's just about 6:30, so... Jake, that's, I'm glad you're getting into Trig. Trig's fun.
Yeah.
And I will talk to you next Monday.
All right, thank you.
You're welcome. Bye-bye.
Bye.